So today I'm gonna talk about the particle colliders, or they are also called as the accelerators. Or almost have heard about the Large Hadron Collider from CERN. In the whole thing very basic, this is the basic diagram of a collider, or I must say a Large Hadron Collider, or a particle collider. Now what we do here, that is, we simply remove an electron from hydrogen to gain a proton. Since hydrogen don't have any neutrons, we get a proton, or we can denote it by positron. And what we do here, we just accelerate a positron from clockwise direction in this direction, and another positron from anti-clockwise direction, or from this direction. So you must be thinking, what keeps the proton from moving in the circular path rather than the straight path? What keeps the protons moving the circular path is these magnets. We have in the corners some magnets, or we can say electromagnets, which are super cooled, that is minus of 273.1 degrees Celsius, or we can say they are absolutely at absolute zero, that is 0 Kelvin. This and this surface are made of very super cooled magnets, and inside is vacuum, or you can say inside is vacuum. So this was a very rough diagram of a particle collider, of simply a ring of the Large Hadron Collider has the ring of radius 27 kilometers. And now if we see the we can say beam of protons released in clockwise direction, another beam of protons released from anti-clockwise direction, they collide here. That's it. And as they collide, a large heat is generated. I will show some pics of that, but now for just look at the diagrams here. Protons are released. Now you must have the question in your mind, how many protons? So let me tell you, 100 trillion protons are released. That means here are 100 trillion protons, here are more 100 trillion protons at 1 second, and thus it increases the probability of the collision of protons. And as the actually proton collides, most elements are made. So this was a very rough diagram of a particle collider having the very super cooled magnets, which keeps the protons moving in a circular path, and inside is vacuum to simply stop the air reaction or air resistance. And due to this stuff, it is called as accelerator, as within fraction of seconds the velocity of these particles become very close to speed of light. Yeah, these particles do time travel. So here are some pics for the particle colliders, or some particles colliding at the velocity of the speed of light. As these particles collide, a very large amount of heat is generated in it. A tremendous amount of heat is generated. So these positron collisions result in some sort of fusion, and this fusion just helps to create some new sort of elements or new sort of particles. Yes, these collisions were once successful to actually detect the Higgs boson particle, or we call it as God particle. The life of these new particles, which are produced by the collisions of these positrons, are in milliseconds, or in seconds, in fraction of seconds. But in this fraction of seconds, our machines are successful in determining its temperature, its half-life, and its mass in giga electron volts, its charge, and all of its properties in that fraction of seconds. And these collisions are promising us that they will provide more new particles, more interesting particles. Higgs boson was just a start. We are to detect much more particles further, much more interesting and useful particles to the mankind. Ones which were never detected before and which would take the mankind to some other generation or the other way of civilization. So here are some pics